Good morning, students. So in the last class we discussed about preparation of aldehydes. So in the today's class I will go with the preparation of ketones and followed by the properties of aldehydes and ketones, because both aldehydes and ketones show similar properties, chemical properties. So before going to the chemical properties of alone aldehydes, I will tell the preparation of ketones. So later I will explain chemical properties of both aldehydes and ketones because they show similar properties. Okay? So listen, preparation of ketones is of only two types. Okay? So the first one is from Friedel-Crafts acylation of benzene. Are you correct? Friedel-Crafts acylation alone. Okay? Friedel-Crafts acylation of benzene of butane. Okay? Next, second one is from dialkyl cadmium compounds. Okay? Two types of systems. So students, first one is Friedel-Crafts acylation. Remember this word, acylation. So initially I will take the reagent as benzene. Acylation means we have to take acyl chlorides. Here they mention acyl means we have to take RC double bond to Cl. This is acyl, RCOCl compound. Okay, so in the place of Cl you may take any X. It may be Br, it may be high, but this is a very stable compound, acyl chloride especially. Understand? So listen, I just reverse this compound. So this one is R, this one is Cl. Both are same. Okay? So this one is benzene, of course. This one is acyl chloride. Okay? Acylation takes place. Acylation is this group. Listen, acyl chloride. Acyl means this group. Acylation means this group is going to attach to this. Okay? So here benzene means C6H6. Each carbon atom consists of hydrogen also. Correct? So then of course what happens here? HCl is going to remain. Okay? So here the reagent used is what? Anhydrous aluminium chloride. This is what? Friedel-Crafts reagent. Anhydrous aluminium chloride is the Friedel-Crafts reagent. So then what happens? Of course HCl is removed. If HCl is removed, so this benzene at this place going to attach with this group. R C double bond O R. Okay? So this is the example of ketone. This one is what? This is alkyl means of course you take this one as a ketone. Understood? So this is what preparation of what is it? Acylation from by using Friedel-Crafts reagent. Friedel-Crafts acylation of benzene. One type of preparation of ketones. Are you getting? So what happens here? This acyl group going to bond to this benzene ring. Means it displaces this hydrogen. Okay? The substitution of acyl compound takes place. So here this is also one, this is also one. This group is what? Ketonic group. So ketone is what? So another one is what? From dialkyl cadmium compound. That is second. Okay, same acyl chloride we are going to use. R C double bond O R. So Cl. Okay. So another one what I told, dialkyl cadmium means two R groups are there which is bonded to cadmium. Dialkyl cadmium. Understand? Of course, no doubt in that. Which one is going to attach here? We want what? R, C couple bond to R we want. Here two R groups are there. So we require two R. Then here it is 2 R, C double bond to R. So this R and this Cl is replaced. Of course, the byproduct obtained is cadmium chloride. Okay, this R you can replace by any alkyl group or aryl group. It may be a benzene, it may be any alkyl group, like you take 2 CH3, C double bond O, Cl plus C2, H5, Cd. Then what must be the reagent here? You take this one is R, this one is R dash, then you get like this. Then this is CH3, this is C2H5. Okay, what is the product found here? Here is CH3, C double bond O, C2H5 plus CdCl2. Both are same, only we are replacing R group. So in the case of R group, here you take benzene, here you take CH3. You get it? So I will write here. This is the benzene ring here. To this benzene ring, C double bond O, Cl is attached. Okay, plus CH3, Cd. CH3 twice, here also twice, Cd. Okay, then what happens here? This is in 2 moles. Here 2 moles of this R group is benzene, and here it is C double bond O. This is CH. This is the product form. Understood? So no matter which R group we are taking here, it may be alkyl or aryl. Okay, the reaction taking place in the same manner. So you have to remember only the general reaction. Understood? So this is preparation of ketone. Only 2 methods are there. In aldehydes, 4 methods mainly. One is Rosenman reduction, Itard reaction, Stephan reaction, Peterman-Koch reaction. All are important. And these two are the for preparation of ketones. Okay. So next we will go to the chemical properties of both aldehydes and ketones. Okay. So next one is chemical properties of aldehydes and ketones. Only the thing changes here what? In aldehyde, CHO group is there. In ketone, C double bond O group is there. And both the carbon is attached to R atoms. Means alkyl or aryl groups. Okay? So that is the difference. So first one is hydrogenation. Or you may call it as reduction. Okay? Reduction in presence of platinum or palladium as a catalyst, 1, or lithium aluminium hydride or sodium boron hydride. By using these two or these two hydrates, they donate H plus ions for the reduction. Understand? So two reactions are going to happen. One is for aldehyde, another one is for ketone. Okay? So I will explain. First, if I take aldehyde as an example. Aldehyde. I'll take the general formula R C double bond O. Here H is there. Correct? R C double bond O H. So I'll just replace this double bond O here, H here. Nothing will changes. Okay? So here it is double bond O. Here it is H for our convenience. No matter you write any one type, for your convenience to understand easily, I write this. So here what happens? Reduction. Reduction means addition of hydrogen. Addition of hydrogen is going to take place. Where the addition of hydrogen takes place? For example, listen, if CH2 double bond CH2 is there. If H2 is added in presence of platinum or palladium as a catalyst, then what is the product formed? CH3 single bond CH3, correct? So this is the product. When what happens here? At the double bond, on either side of the atoms, hydrogen is added. Here, where is double bond present? Here. On either side of the double bond, H is going to attach. So you may take here initially platinum or palladium as a catalyst. Finely powdered platinum or palladium. Why we need finely powdered? You know that in the surface chemistry chapter I already explained. If finely divided catalysts are there, they provide more surface area for adsorption. That's why we have to take finely divided platinum or palladium as a catalyst. Okay? So then what happens? R I will take as a common. So CH is common, double bond O is common. Okay? So here what happens? Hydrogen is added, means this bond is removed. On either side of the atoms, one is 2 hydrogen, one is here. So general reaction is what? R, here it is CH2, here OH. So from aldehyde, upon reduction, it gives which product? Alcohol. Which type of alcohol it is? Primary alcohol. Because the OH to which, the carbon to which OH is attached, that is further attached to only one carbon atom. So that is primary alcohol. Understood? Means, so aldehydes upon hydrogenation or reduction in presence of any catalyst, or it may be these hydrates, primary alcohols. Okay? So if you want to take any, so you may write here aldehydes undergo reduction. So in the place of reduction, you may write hydrogenation in presence of platinum or palladium as a catalyst. You have to write a complete sentence. Platinum or palladium as a catalyst gives right here, okay, primary alcohol. This is the statement. So if we take example, this R may be replaced by any alkyl group or aryl group. So I will go with the simple examples. This I will take as R as a CH3. CH3, CH double bond O. I will take CH4. Then what happens? Hydrogen is added here. Palladium as a catalyst. Okay. This one is right here, aldehyde. Then the product formula is CH3 here, CH2 OH. Nothing is changed. Only changes is what? R group is replaced with the respective group, that is CH3. Okay? So this one is what? Ethanol, AL. This one is ethanol. Okay? So then you have to write this. Ethanol undergoes reduction ethanol undergoes reduction in presence of platinum or palladium as a catalyst. Platinum or palladium as a catalyst gives ethanol. Ethanol undergoes reduction in presence of platinum or palladium as a catalyst gives ethanol. Okay, what is the difference here? Only the aldehyde is replaced by aldehyde, the name of the aldehyde, and the alcohol is replaced by name of the alcohol. Remaining everything is same. In the reaction also, R is replaced by this and R is replaced by this. Nothing will change. The reaction remains same. Only you have to replace R. Okay, so students, instead of this, the second one is you may take lithium aluminium hydride or sodium borohydride. Same aldehydes undergoes reduction, but in presence of platinum and palladium changes to lithium aluminium hydride or sodium borohydride as a catalyst. Are you getting how to write the explanation? In the presence of platinum and palladium we took, because we use platinum and palladium as a catalyst. But here we are using lithium aluminium hydride and sodium borohydride. So we have to write in the presence of sodium borohydride and lithium aluminium hydride. Then we will get the primary alcohol. Similarly, here if you replace this one by lithium aluminium hydride and sodium borohydride. Okay, so then what happens? This ethanol undergoes reduction in presence of lithium aluminium hydride or sodium borohydride as a catalyst gives ethanol. This is the explanation. And in this, what you have to remember for NEET, they won't give this H2 like that. They simply give aldehyde. So here I say, they simply give any aldehyde. Okay, so here they give lithium aluminium hydride. Okay, then they are going to ask product for you. Then you have to remember, if lithium aluminium hydride is there, the product carbon must be an alcohol because reduction undergoes. Okay, next, in the place of this, they may give platinum or palladium and they are giving some options here A, B, C, D. In that one must be the ethanol or alcohol, anything. Primary alcohol, secondary, tertiary, etc. And alkene also they may give. Understood? Okay. So then this you have to remember reduction will happen. Reagents you have to remember what happens. Okay. So R they may give. Here we give R CH2OH. So here you want to find out the reagent. So in the option A, they may give platinum or palladium. Okay. In option B, they may give KOH because OH is attached here. Okay. So in the third one, they may give H2 because they will think if H2 is there, then only this CH2 is there, OH is there. Hydrogen they may give. So in the option B, they may give none of the above or all of these. Which one is the correct option? Platinum and palladium. Even this type of questions they are going to ask in the NEET. So we want what is the exactly we cannot say which type of questions are going to arise even in the exam, board exam, as well for 1 marks I am telling in the NEET examination. Of course, for 3 marks, 2 marks, 5 marks, they'll ask only pros and cons. What I said, the name and reactions and the mechanism, they are only that is compulsory questions. 2, 3, 4, 5 marks, they will not affected by any of this such type. Okay, only 1 marks question, because if you want to score 70 out of 70, you have to attend all the 10 questions which are in first minute. Then only you will get out of it. Otherwise, you will, you know that 99 is not exactly 100. Okay, so you more concentrate on this. This is one type of reaction using aldehydes. So the next one is How the ketones undergoes reduction or hydrogenation. Ketone. Okay. So general formula of ketone ante R C double bond O R. Okay. Next, it undergoes hydrogenation in presence of platinum or palladium as a catalyst. Ketone undergoes hydrogenation in presence of platinum or palladium as a catalyst. First, listen. Here also, as I told you, the addition reaction. Hydrogenation means addition of H2 takes place at where the double bond present. So remember here, R is there, C double bond O is there, R is there. So this is going to remove. Means one hydrogen is attached here, another hydrogen is attached here. R, CH, OH, R. So listen, this is the OH group. Sorry, this is the carbon where OH is attached. That is further attached to 2 carbon, means it is a secondary alcohol. It is a secondary alcohol. Understood? So next you have to write here ketone. Ketone undergoes hydrogenation, aromatic reduction in presence of platinum or palladium as catalyst. Gives secondary alcohol. Understood? Gives secondary alcohol. How the reaction takes place? Just take a minute. So just to replace this R group by CH3. CH3, C double bond O, CH3. Okay, next H2 in the presence of platinum or palladium. Next, you will get CH3, CHOH, CH3. So students, this one is propanol or propan 2-ol. So this one is propanol. It's propan 2-ol. Propanol. Second position double bond is there. Sorry, CO group is there. Second position OH group is there. Understood? So now propan 2-ol undergoes hydrogenation or reduction in presence of platinum or palladium as catalyst gives propan 2-ol. This is the reaction or explanation. Gives propan 2-ol. Okay, so this is what hydrogenation or reduction of aldehydes and ketones. So in the place of platinum palladium, as I told you, we may take lithium aluminium hydride and sodium borohydride. The reaction follows the same thing. Only the changes is this explanation. So in the presence of platinum and palladium, you have to take lithium aluminium hydride and boron sodium borohydride. Understood? Only that will change. You may take here lithium aluminium hydride and sodium borohydride. Remember students, you cannot take platinum and lithium aluminum hydride and palladium and sodium borohydride. Either you have to take these two or these two. These two are hydrates, these two are metals. Okay, you cannot take these two at a time, these two at a time. You can take platinum at a time and lithium aluminum hydride or boron sodium borohydride at a time. Okay, so just remember, and all these four are the reagents for reduction. Remember that wherever they said platinum and palladium, not only in this, not only in aldehyde, not only in ketone, in alkyl halides it may be in what is that, alpha, in amines, okay, in alkanes, alkenes, alkynes, wherever it may be, platinum, palladium, and these four reagents are always there purpose reduction. Understood? So in the yesterday's class also I told, in the Rosenberg reduction reaction, they used palladium as a catalyst and BS24 as a catalytic poison. All reduction process, the most suitable catalyst are these. Okay? So this is one. The first chemical property. So listen, I gave only example of aliphatic compound. So I take the example of this one. Benzene, C double bond H. What is the name of this compound? What is the name of this compound? Here CH2 group is there, benzene is there. This is benzenol. Correct? So it undergoes hydrogenation in presence of related platinum or palladium as a catalyst. Just go through this only. Next, they form CH2 because double bond is present here, one H is attached here, another H is attached here. CH2OH. We don't bother about this R group, only here it is taking change place, however CH1OH. Okay, so this is what benzyl alcohol. In the last class I told you, so if it is CO is there, then it is benzoyl, ketone is there. Then this is there, so CH2OH like this, another carbon atom only there, or alkyl group is there, then it is benzyl. Okay, so here you have to write benzenol undergoes reduction in presence of platinum or palladium as a catalyst gives benzyl alcohol. Okay, so next I'll take the example of ketone. C double bond O CH3. Okay. You may take it as acetophenol. Acetophenol, the name of this compound. This one is acetophenol. Okay, so it undergoes hydrogenation, of course, in the presence of platinum and palladium as catalyst. Then they form CH, OH, CH3. Okay, so students, what is the name of this compound means? You have to take this one as the parent chain. This one is the parent chain with the two carbon atom means ethane. At first carbon atom OH is attached. First carbon atom means C6H5 is attached. So it is 1 phenyl, okay, ethane, 1 or. This is the name of the compound. 1 phenyl, ethane, 1 or. So this is, listen, the OH which is attached to one carbon, that is further attached to two carbons. So this is a secondary alcohol. This is a primary alcohol. You know that difference. Aldehyde is the primary alcohol, no matter if it is aromatic or aliphatic compound. Ketone is the, that is secondary alcohol, no matter it is which type of alcohol or which type of pH it is. Understood? This is the first property, hydrogenation and reduction. So the next one is Clemmensen reduction. Clemmensen is Indian. Clemmensen reduction. Okay. So here this is also reduction. Why it is called as Clemmensen reduction means because they are using zinc amalgam as a reagent. Zinc amalgam as a reagent in concentrated HCl. These are the special type of reactions. This is also a reduction. Reduction means what? Addition of hydrogen. Addition takes place in the same way. If aldehyde is the primary, if ketone is the secondary. Alcohol only they will form. But here the reagent used what? Zinc amalgam in concentrated HCl. This is called as Clemmensen reagent. Understood? So I'll write only the general reaction because as I give you already an example. So I'll take aldehyde here. Okay, aldehyde means RCH double bond O. Of course, reduction means addition of hydrogen is this, but this hydrogen is taking like this 4 moles of H2. Okay, so listen students, what is the expected product here? If hydrogen is added, remember later I write 4 hydrogen and 2 hydrogen. What is the expected product here? Alcohol, primary alcohol. So if we are using zinc amalgam in presence of concentrated HCl, the product formula is RCH2 or CH3 plus H2. This is what? Higher alkane. Okay. Higher alkane will form. Understood? Means here 4 moles of H2 is going to add it. What is the expected product here? Alcohol. But instead of alcohol, what is the product we are writing? Higher alkane. That is what Clemmensen reduction. Understood? If platinum, palladium and that lithium, aluminium and sodium boron is there, alcohols are the products. If this zinc amalgam is concentrated and say it is a special reagent, if it is there, then they form higher alkanes. Are you getting? Here RCH3 for aldehyde. So for example, if you take here CH3, CH. So how the reaction will take place, I will explain that also. Listen, hydrogenation initially what they will form? What they will form? H2, addition of hydrogen means initially they will form CH3, CH2, OH. Again to this H2 is added. So here it forms CH3, CH2, another H is added here. From this So this H and OH minus combined with each other form H2. That is what I wrote there. Double reduction takes place. 2 times hydrogenation takes place. So that's why I took 4 moles of H. Understood? So then this is the reaction happens when we are going to use that zinc amalgam in concentrated HCl as a reagent. So if we have to write aldehyde undergoes reduction or aldehyde treated with, just try to change the definition because it is not the only way to write aldehydes and glucose reduction like that. We may write like this. Aldehydes treated with zinc amalgam. You may write like this also, and in the writing sentence, zinc amalgam. Okay, in presence of zinc amalgam with concentrated HCl or activated zinc amalgam and concentrated HCl because I already know big here. Zinc amalgam and concentrated HCl gives or here you take undergoes reduction to give higher alkane. To give higher alkane. Okay. So if I take an example, CH3, CH double bond O plus 4H will get zinc amalgam in concentrated HCl. So what we will get? CH3, CH3 plus H2O. So students here, ethanol when it is treated with zinc amalgam and concentrated HCl, so it undergoes reduction to give higher alkane. Which one it is? Ethane. Or to give alkane you take. Instead of higher alkane, you take alkane. Because here also 2 carbon atom, there also 2 carbon atom. Higher alkane means 1 carbon is more. Okay, same number of parent chain is there. So to give alkane, that is enough. You may take benzene. Benzene is there. Here CH double bond O is there. So this is 4 moles of H. So here it is zinc amalgam in concentrated HCl. What is the product formula? This R is replaced by this benzene ring, and this is also CH3 plus H2. Methyl benzene. Of course, this is also alcohol. Sorry, this is also alkane. Understood? So this is a reaction happens when the Clemmensen reduction. This is the special. Why it is called as Clemmensen? Is the scientist Clemmensen, by using this reagent, they proved this reaction. Understood? And this one is Clemmensen reagent. Okay, so remember how to remember the reagents means you have to remember, so like platinum and palladium or lithium, aluminium and so on. So then they form alcohol. Okay, in that first one, aldehyde gives primary alcohol, ketone gives secondary alcohol. You have to write like this. So listen, that too in this form, aldehyde gives primary alcohol. This is the correct way to write. And ketone gives secondary alcohol. Understood? To remember key points entered. Next, so instead of this, in the reduction, if they use zinc amalgam and concentrated HCl, okay, aldehyde gives, of course, what is it? Alkane. Aldehyde, right? Ketone also gives alkane. This is the key things to remember. Which reagent gives which product. Okay, if you know this the functional groups, then you can answer easily. Understand? So this is aldehyde. Now the ketone. This is the very important chapter, so I am going so slowly as much as possible. I am going to cover all the topics. Listen, the second one is ketone. The general formula of ketone is R. Okay, so here zinc amalgam presence of concentrated HCl. Of course, here also 4 moles of H is required because, so listen, RC double bond 2, R is there. So this oxygen is removed with the 2 hydrogen atom as H2O and another 2 hydrogens added here. Here 3 carbon atoms, here also 3 carbon atoms. So they form alkane. So this one is ketone. Ketone is the alkane. Okay. So how to write ketones treated with, you may write Clemmensen reagent also. What is the Clemmensen reagent? Zinc amalgam in concentrated HCl. Undergoes reduction. In the place of reduction, you may take hydrogenation to give alkane. Okay, this is the main reaction. So you just replace this R group by CH3 and benzene. Then you will get the example. Okay, you write yourself. So in the tomorrow's class, we will continue with the next properties of these aldehydes and ketones. So many properties are there still. Okay.